Hi, I'm Pawan Karkun, and I'll be talking about the Lunar-Lander project. So, Lunar-Lander is an environment where the lander intention is to land on a specified landing pad. It can do four of the actions: either do nothing, fire left, fire right, or fire the main engine to land. So, the rewards are adjusted depending on how favorable or how accurate the landing was. The approach I chose is a multi-layer neural network with ReLU activation. I'm using Keras and TensorFlow with loss function mean squared error. There is also a memory component which is used to store the experience of the agent as to the state, action, reward, and the new state tuple. So this is used every now and then after an episode or so to teach the learning agent the experience that it had in the past, because the neural networks this way tend to forget the past experience, and every now and then we need to adjust the neural networks with the history so that they perform better. So during this step, we do a similar to a queue table update, where we update the current state and action depending on the reward that we got at the specific state in past, and also a discounted uh, potential future reward. So this experience replay can be done at two phases, either after every episode or after every step. So I'll be discussing the performance of each of them down and further. The optimizer that I used is Adam from the Keras library. I also tried AdamX, which is supposed to be a sophisticated version of Adam, but since I did not have a GPU, it did not perform that well. My agent with these hyperparameters was able to solve the Lunar-Lander problem with 12,000 iterations. The learning rate was 0.05, 0.995 of discounting rate gamma with epsilon decay, Adam optimizer, and a multi-layer neuron network of 512 and 256 neuron each. So here is the learning curve. As you can see, around 12,000 iterations it was able to solve with an average of 205.9 rewards. Here we have plotted the state and action discretization that was done by the function approximation method. As you can see, the action discretization is pretty good, and we were able to cover almost all the actions, but state discretization was not that great and needs to be looked at. This is the plot for the 100 episodes using already trained agent, and no epsilon or exploration, only greedy actions involved. As you can see, the average was mostly above 120 to 130 rewards per episode. So these are the hyperparameter tunings that I did. The more details about this can be found in the report. Two approaches I did was epsilon decay after every episode and epsilon decay after every step. The every step epsilon decay led to a epsilon reaching to 0 after almost 15 episodes, and that led to a very low exploration and mostly greedy operations, which was not favorable. That's why I stuck with epsilon decay after every episode with a epsilon decay factor of 0.995 that gave a that was able to solve the problem. So here I have listed the openAI leaderboard links for different hyperparameter tuning that I experiments that I did, and eventually what I arrived at was the one with a learning rate of 0.05 and epsilon decay of 0.995. So the two options that I told you about earlier, replay after every step versus replay after every few episodes. It turns out that if we do a memory replay from the experience after every step, the agent did not really learn anything and the curve was mostly flat. So this is why I went ahead with an experience replay after every episode, which was able to solve the problem. In conclusion, the deep neural network that I used with 512 and 256 neuron in two layers with a batch replay of 32 memories from the experience was able to solve the problem in 7 hours on my machine without GPU. Thank you.